Let's see how quickly I can put you out of your misery on this one. This is, of course, the review for your test based on page 541. The test will be on our last day, Thursday at 1 o'clock. But Mr. Peer, you can't do that. Math tests are on Fridays. There's a problem with that. There is no Friday next week. Wow, it's coming fast. How can that be? I'm talking about next week? Really? Am I somehow a week off? Is next week our last week? It sure is. Goodness. So, yeah. Have special permission from the higher-ups to do this. I've checked with the other teachers. There are no conflicts with having more than one test on a day. Also, because the school day officially ends on Thursdays at 12:45, there can be no other class conflicts at 1 o'clock. So that's it. Like it or not. That gives me the honor of having the last word of the year. Okay, let's see how quickly we can get through this. This is trivial. Folks, I refuse to review why, if you've got a right triangle and the legs are 3 and 4, I'm not telling you why the hypotenuse is 5. We just move on. Now, from there, lean heavily on our old friend, SOHCAHTOA. Be sure you spell it right. SOHCAHTOA. SOHCAHTOA got me through college and beyond, and I still think through SOHCAHTOA to this day, so many years later. Remember SOHCAHTOA always. The sign of theta. Sine is opposite over hypotenuse. Here's theta, opposite is 4, hypotenuse is 5, sine of theta is 4/5. We don't even care what theta is. We could figure it out, but we don't need to. Cosine of theta, cosine is adjacent over hypotenuse. Cosine of theta is adjacent over hypotenuse, that's 3/5. Tangent is opposite over adjacent. Tangent is opposite over adjacent, that's 4/3. And folks, I do not want to catch anybody on this last opportunity of the year to raise your grades. I do not want to catch anybody getting confused about where the hypotenuse is and where the adjacent is. I find in geometry tests, 10th grade geometry tests, that if I have the triangle in a strange orientation, folks get all messed up. If I tell you this is 8 and this is 3 and you've got to find this guy, I have folks who actually say 8 squared plus 3 squared equals x squared. No. When you use Pythagorean theorem, a squared plus b squared equals c squared, the hypotenuse has to be in the c position. So this would be 8 squared. And in SOHCAHTOA, if I'm looking at, say, this angle, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Don't get messed up if the triangle's orientation is a little bit different than you're used to seeing. All right, continuing. The rest of these are trivial because cotangent is indeed the reciprocal of tangent, so it's 3/4. Secant is the reciprocal of cosine, so it's 5/3. And cosecant is the reciprocal of sine, so it is 4/5. Oops, no, it's not 4/5. It's 5/4. And unless I did something silly in my haste, those are all correct. Yes, we move on. Number 3. Again, applying SOHCAHTOA, but before we do that, we need to know what the missing side is. So we use Pythagorean theorem. And we can use that because it is a right triangle. Do not try to use Pythagorean theorem if it's not a right triangle. That should be obvious from your experiences in pre-algebra, perhaps even, and geometry from long ago. So we use Pythagorean theorem. We've got 2 squared plus the unknown, I'm calling it b here. B squared equals c squared. Remember, c is always the hypotenuse. C is always the side opposite the right angle. C is always the longest side. A speech I usually give a little more slowly to the 10th graders. So we have subtracting 4 from 16, we get 12. B squared is 12. Take the square root of both sides, and we have b is the square root of 12, better known as 2 square root of 3. We are not going to get a decimal approximation for that. It has not been called for. So with that in mind, we now know, let's just change that b into 2 square root of 3. And from there, it's just like the previous problem. A little bit of simplifying of radicals to do. Can I erase this and make some space? Thank you. I appreciate your permission. But I didn't give my permission. Tough. Sine of theta, opposite over hypotenuse. That would be 2 square root of 3 over 4. Do I expect you to reduce the fraction? Yes, I expect you to reduce the fraction. That's been an expectation ever since about 3rd grade. So we have 1/2 square root of 3 over 2. Cosine being adjacent over hypotenuse, 2 over 4. 1/2. Tangent of theta, tangent being opposite over adjacent, that's 2 square root of 3 over 2. But 2 square root of 3 over 2, hey, do the 2's cancel? Of course they do. Square root of 3. From there, it's reciprocals. What's the reciprocal of square root of 3? You may know it right off the bat, or you may have to slow down and think about it. The reciprocal would be 1 over square root of 3, but then you multiply by square root of 3 over square root of 3, you get square root of 3 over 3. Done. Square root of 3 over 3. I'm not going to review the details of how to simplify a radical. Come on, guys. This is pre-calculus. You're going into calculus next year, maybe. Secant is the reciprocal of cosine. Remember, this bracket thing works only if you have them written in what I call the natural order, that order that Sullivan never uses. Sine, cosine, tangent, cotangent, secant, cosecant. All right, so the reciprocal of 1/2 is 2. And cosecant, the reciprocal of sine would be, let's just deal with this one, 2 over square root of 3. But you know the story. You've got to multiply by square root of 3 over square root of 3. That gives you 2 square root of 3 over 3. We're done. And I've got the answers down here just in case we messed up someplace. And I'm confident we did not. And a quick peek tells me that we didn't do anything silly. I didn't do anything silly. They are all correct. Yes. Okay, we move on. All right. Oh, this is easier than it looks. This depends on that concept of the cofunctions. Cofunctions of complementary angles are equal. So that means that the tangent of 15 is actually equal to the cotangent of its complement. The tangent of 15 equals the cotangent of 75. Oh, so these two are equal? Well, if we subtract two equal numbers, don't we get 0? Yeah, of course. Here, likewise, tangent of 40 is exactly the same thing as the cofunction, cotangent of the complement 50. So, did I just say the wrong, or I don't know what I just said. But this becomes tangent of 40 over, yeah, I did say the wrong thing. The cofunction of tangent is cotangent. The complement of 40 is 50. So this actually becomes tangent of 40, which is 1. These two things are equal to each other. A number divided by itself equals 1. We move on. Number 10. This leans on one of the fundamental identities. They are listed for you on page 379. You need to be aware of these fundamental identities or you might be in trouble. No, don't just be aware of them. Know them. There are what? There are 7 or 8. I don't recall now. And they're not hard to remember. You're expected to know this. What good is that going to do you? Well, what happens if I were to... Well, first of all, let's remember that the angles are different. You say, oh, what are we going to do with that? Well, remember that cofunctions of complementary angles are equal. So let's change cosecant squared of 50 into its cofunction, which would be secant squared of 40. Cofunctions of complementary angles are equal. So I can change this into that. So what? Well, looking back at our fundamental identity here, what if I were to take this and subtract 1 from both sides and subtract secant squared from both sides? If I subtract secant squared from both sides, it suddenly looks like this. And if I subtract 1 from both sides, I get that. It's equal to -1. So it comes down to knowing that the cosecant squared of 50 is exactly the same thing as the secant squared of 40, and then manipulating this guy a little bit to make this look like, or to make that look like this. Subtract 1, subtract secant squared, and we're done. Moving on. Number 12, if you are given a right angle, then please just use SOHCAHTOA. Keep life simple. So I'm looking for angle B. Well, let's see, what did I find here first? Sine of 35. No, I'm not going to find, I'm finding C first here. So starting with the 35-degree angle. I look at my 35-degree angle, I ask myself, what am I given and what am I looking for? So I'm going to use opposite and hypotenuse. Opposite and hypotenuse. That would be right there, opposite and hypotenuse. So I'm going to use sine. Sine of 35 is 5 over c. 5 over c. I then go to the calculator, look up sine of 35. Do we need to go through all this? Sine of 35, killed that. Sine of 35 is approximately 0.5736. So I have 0.5736 approximately equals 5 over c. Tiny bit of basic algebra, multiply by c, divide that into 5. So I've got 5 divided by the answer to the previous problem, and I end up with c being approximately 8.72. Checking my answer, 8.72. There it is, correct. And from there, let's do the to find b, let's use the tangent of 35. Why? Because I now know, well, no, never mind, forget about what I now know. I've got my opposite, let's change colors. I've got the opposite and the adjacent. Hey, don't use that estimated value. Yes, we know that c is about 8.72. That is approximate. Don't use an approximation to find the remaining variable when you can use an exact number instead. So no, we're not going to use opposite over hypotenuse here. I'm sorry, we're not going to use adjacent over hypotenuse. We're going to use opposite over adjacent. Tangent of 35 is 5 over b. By the way, if you don't like having the variable in the denominator, no big deal. But if you don't like it, we can always switch to the other angle. What's the other angle going to be? The other angle is going to be 55. Because these two have to add up to 90. By the way, that is one of your 3 answers. They did ask you for everything. B is 55. So I could switch to this angle and use tangent of 55 equals b over 5. Tangent of 55 equals b over 5. A little more convenient. We find the tangent of 55. Tangent of 55. And I will close the parentheses and just multiply that by 5. And we get about 7.14. About, b is about 7.14. And yep, there it is. So we're done. We move on. Number 14. Oh, what are we looking for here? We're looking for angles A and B. Are we looking for everything? What do they want us to find? Yep, everything. Okay, so what have I got going here first? Pythagorean theorem. If you've got a right triangle and you know 2 sides, just use Pythagorean theorem to get the missing side. A squared plus b squared equals c squared. That's going to be 9 plus 1, that's going to be 10, so c is the square root of 10. And square root of 10, that ends up being 3 point something. C ends up being about 3.16. Okay, that was the square root of 10. All right, from there. What did I say that was 3.1? I've forgotten already. Such a short memory. 3.15? 3.16. 3.16. All right, now, to find the angles. Let's use tangent of A. Because to find A, if I use tangent, I've got the opposite, I've got the adjacent. I don't want to use sine or cosine, because I don't want to have to use an estimated value to do these calculations. I'd rather use exact values. So I will stick with tangent, opposite over adjacent. Tangent of A equals 3 over 1. Tangent is 3 over 1. So that equals 3, of course. So I want the inverse tangent of 3. So I go to the calculator. Hey, you better have your good calculator handy for this test, obviously. So to do the inverse tangent, I hit second tangent of 3, and I get a result of approximately 71 point. And the book asks us to round angles to 1 decimal place, so I'm going to call it 71.6. And that should match up here. And then now that we know angle A, and we also know angle, oh, okay, of course that's 90, so we know these two have to be complementary. That leaves us with only one thing for angle B. It's got to be 18.4. So that these two add up to 90. All right, number 16. In this case, no diagram. We're going to use law of sines. What's the law of sines say? And yeah, you have to know the law of sines. But the law of sines is really easy once you get used to it. Law of sines says a sine of A over A equals a sine of B over B, which equals a sine of C over C. By the way, I've come across algebra students who don't seem to understand that in algebra, there's a difference between uppercase and lowercase letters. If you make everything lowercase or make everything uppercase because you think it looks better or something, you're going to struggle. Because capital A and lowercase a are not the same thing. So if you are in the habit of always using uppercase or always using lowercase because you think it's somehow cool or something, stop doing that. You'll make a fool of yourself in your college classes. Okay, so moving on. What do we have? We know what A is. So we have the sine of 10 over, and we do not know the value of little a. That's going to be equal to the sine of C over C, which we do have. There we go. We'll deal with B and B later. So from there, it's just a matter of doing the math. Let's see. We can multiply by A and multiply both sides by the reciprocal. Long story short, do the algebra, do the math, fill in the numbers, use the calculator. You better find out that A is 0.54. I'm not going to take time. I'm not going to bore you by going through the details. We do the same thing to find B. All right. And oh, by the way, angle B is easy because if these two add up to 50, then B must clearly be 130 because they've got to add up to 180. That's trivial. B is 130. You know, even if you can't do anything else, you should not have a 0 on this test because there are some things that are just that easy. Angle A is 10, angle C is 40. I wonder what angle B is. They have to add up to 180, of course. You've known that since you were little people. So you have to at least get that one right. Then to find B, we just again fill in the blanks. We would have, I would start with sine of C over C. Sine of C over C. Wait, what's C? C is 40 over 2. Sine of 40 over 2 equals, and then sine of B, and B was 130 over little b, and then do the math, you get B is approximately 2.38. Folks, if you can get this far, but then can't do the math and get this, I'm sorry. We move on. For this guy, if you try to use the law of sines, how do you know which one to use? If you try to use the law of sines, you'll find out you've got too many variables in the wrong places. You can't solve it. You end up with equations with 2 variables, and you're going, what do I do now? Yeah, law of sines won't hack it. If you accidentally try to use the law of sines, you'll quickly see it's not going to work. So we resort to the law of cosines. In this case, we have A and C. We're missing B. Because we're looking for B, and we have angle B, then we start with b squared, the one that we're looking for. A, C, we're missing b. We start with b squared. B squared equals a squared plus c squared. The two things you didn't use here go there and there. Then minus 2 times the same two variables, a and c, times cosine of the, I'll say the letter you haven't used yet, or the angle associated with this guy. Works the same way every time. So what's that give us? Notice we don't even need a diagram. So we know that b squared is a squared, that's 9, plus c squared, that's 1, minus 2 times 3 times 1, times the cosine of 100. Do the math, and please do not make a mistake. 9 plus 1, 10. 2 times 3, 6. Do not make the mistake of doing 10 minus 6. If you do 10 minus 6, shame on you. That's a pre-algebra kind of mistake. Multiplication is done first. You have to do 6 times cosine of 100 first, and subtract that answer from 10, because multiplications come before subtractions. You do 10 minus 6 and multiply 4 times cosine of 100, you get what you deserve. Then once you've done that math, don't forget to take the square root, and you're done. And the bottom of the board here says b ends up being about 3.32. Define what's left. To find angle A, we once again use law of cosines. We're looking for angle A, so we start with a squared, which we now do know. Well, we knew it before. That's 9 equals b squared. Well, we know what b is now. B was, where is it? Oh, right there. 3.32, approximately. 3.32 squared plus c squared minus 2 times b times c, 3.32 times 1, I'll leave that off, times the cosine of my unknown angle. Notice I know everything except the angle. So, long story short, do the math. Do the math. And given this, and figuring out this guy, add 1, subtract it from both sides, then do what here? You'll divide both sides. Once you get rid of this stuff to the other side, once you get rid of that, you will divide both sides by what? Negative 6.64. Negative 6.64. That's 2 times 3.32. You'll divide both sides by that. And you should end up with, oh, and that'll just give you the cosine of A. So we will have cosine of A equals whatever all that stuff turned out to be. It's just arithmetic. And then you'll use the inverse cosine function and find out that A is approximately 6.28. And that will lead to a conclusion that C must be 17.2 because your 3 angles have to add up to 180. Whew. Yeah, I know I'm kind of rushing through it. I just don't want to bore you with a whole bunch of arithmetic. If you can't handle solving this, again, I'm speechless. Okay, moving on. 24. All right, what's going on this time? We're going to use law of cosines again. I know A, I know B. I don't know C. Oh, I do know C. I know them all. What I don't know are the angles. Since I don't know any of the angles, you can start with any one of the 3 law of cosines you feel like starting with. I started with A because it's first in the alphabet. No better reason. So I have A squared equals B squared plus C squared minus 2 times B times C times cosine of angle A. So I fill in my blanks. That's 100 equals B squared, 49, plus C squared, that's 64, minus 2 times B, which is 7, times C, which is 8. And all of that is then multiplied by cosine of my unknown angle. Do the math, and please remember, please, I will beg you one more time, do not take that guy and subtract this guy. This is multiplication. You can't do that. You'll add these, subtract it from both sides. then you'll divide by 2 times 7 times 8. Negative 2 times 7 times 8. And then take the inverse cosine. To find another, and you'll have to do the same thing again to find another angle. At that point, we could use law of sines if we want to. I stuck with law of cosines. So I chose to do b next. So b squared is a squared plus c squared minus 2 times a times c times cosine of b. We fill in what we do know and solve for angle b. Again, 164, subtract it from both sides. Then we'll divide by this guy, because this is multiplication. And we're off. Strange things going on out there. Okay, so your answers, angle A ends up being 83.3, B is 44, C is 52.6. There they are. Again, I'm going to trust that you're able to do the arithmetic and the basic algebra for yourself. Number 34, looks like it's more of the same. We're given angle C, so we're going to find C squared, which we do not know. So C squared equals A squared plus B squared minus 2AB times cosine of 60, cosine of C, cosine of C. We fill in the blanks. We don't know C. A squared is 1, B squared is 4, minus 2 times 1 times 2, cosine of 60. By the way, cosine of 60 is the same thing as the cofunction of the complement. And you might already know the sine of 30 without the calculator. Yes, the sine of 30 is 1/2. How nice. So we have here 5 minus 2 times 2 times half is going to be 2. That's going to be 3. So C squared is 3. Therefore C, please don't forget to take the square root. C is the square root of 3. And square root of 3 is about 1.73. We're done. We move on. Number 36. Okay, why is 36 so big blank? What's number 36? I don't have it in the board. Sorry about that. 36. Oh, finding area. Where B is 5. C is 5 also. And A is 20. Took my eyes off the spot there. All right. So, the formula for area. And here I'm going to embarrass myself by telling you that on the spur of the moment here, I'm temporarily forgetting the formula for area. My brain went blank, so I've got to flip back and do what you must not do during the test. Oh, come on, where's the formula for area? I know what it is, but it's just not coming to my head. Oh, it's 1/2 AB sine of C. K equals 1/2 AB sine of C. Or, if I know what angle A is, it would be 1/2 of B times C times sine of A. So B and C are 5 and 5, so that's going to be 1/2 of 25 times the sine of 20. And let's go ahead and pull out the calculator here and verify it. Cool thing is, I can just punch it right into the calculator without having to write anything down. I've got 1/2 25 is, of course, 12.5. I'll just put in 12.5 times sine of 20, and I get about 4.28. And I don't have the answer written down there, but I'm confident it's 4.28. And why do I have doubts about myself? Well, I always have doubts about myself. And I've lost my page for the answer, so never mind. Number 42, likewise, I didn't put in here. Bummer. 42 is one of these cool ones. We've got A is 3, B is 2, and C is also 2. An isosceles triangle. So, we know Heron's formula. When you have the 3 sides and you don't have any angles, that's when we use Heron's formula. Heron's formula says, first of all, that the area is going to be the square root of a really big, nasty-looking creature that's easy to remember. It's going to be S times S minus A times S minus B times S minus C. See how easy that is? But what in the world is S? There's no S up here. Definition of S. S is 1/2 times the sum of A plus B plus C. That's all there is to that. So, we dive in with our numbers here. Let's find S first. S will be 1/2 of 3 plus 2 plus 2. They love those fractions, don't they? 3 plus 2 plus 2, that's going to be 1/2 of 7. That's going to be 7/2. So S is, sorry, on the test I would not give you fractions. But it's going to be 7/2 for S. So I have the square root of 7/2 times 7/2 minus A is 3, but let's write that as 6/2, okay? Times 7/2 minus B, but let's write that as 4/2. It'll make our arithmetic a little easier. And then we have 7/2 minus C, which is 4/2. And basically we're done. Do the math. A square root of 7/2 times 7/2 minus 6/2 is 1/2 times 7/2 minus 4/2 is 3/2 times 7/2 minus 4/2 is 3/2 again. That gives us the square root of, let's see, 7/963 over 16, and that's basically it. Since they wanted a decimal approximation, we do not need to simplify the radical. We just need to find the square root of 63 divided by 16. And my calculator says we get about 1.98. And do I have the answer down here? No, I don't. 1.98, I trust it's correct. And if it's not correct, somebody send me an email and chew me out, and I will send a retraction. And I think the last one coming up. No, that was the last one? Is that it? Only one Heron's formula problem on the assignment? Yep, that was it. We're done. Okay, folks. The next thing you're going to hear from me is the test. So you have no assignment due on Monday. No assignment due on Wednesday. All you have to do is look at the videos about 75 times each until you've got this nailed so that you can also nail the test. See you then.